Good morning, students. Students, on the last turn we had completed our chapter of bio, chapter or environment. Beside that, I had given project work from chapter management of natural resources on 1610 or on Thursday. And on the last turn, we have also discussed the worksheet of chemistry that was based on chapter metals and non-metals. So today we are going to start our next chapter, and the chapter of chemistry, that is carbon and its compound. Carbon, as you all know, that it is a unique element. It is a non-metal which exists in nature both as in free state and also in combined state. In free state, it occurs in Earth's crust as coal, then diamond, then graphite, etc. But in combined state, it occurs in many things, like in atmosphere it occurs as CO2, and its percentage in atmosphere is 0.03 to 0.04%. Beside that, it is present in rocks as calcium carbonate and magnesium carbonate. Then it is found in fuels, oils, natural gas, wood, paper, plastic, drugs, medicines, then dyes, textile fibers, insecticides, etc. It forms the main part of all livings. It is found in all living things. It forms the tissue of our bodies. Beside that, it is found in foods that we eat, like sugars, proteins, fats. So these all are sugars, fats, proteins. These all are the compounds of carbon, or compounds of carbon in combination of other elements. When we take food, or when the food that is digested in our bodies, it changes into glucose. Firstly, the food that we consume, it changes into glucose and some other materials. In our metabolic process, glucose combined with oxygen of air to produce CO2, water and energy, and the CO2 produced in reaction or in the metabolic process, we breathe out it, and the reaction that takes place, that is in this form, C6H12O6 plus O2, it forms a CO2 plus H2O plus lot of energy. This energy makes us able to do the work or activity that we daily do. Beside that, on page number 58, an activity is given, activity number 4.1. In this activity, it is given, if we make a list of 10 things that we have used or consumed in the morning, and from the list, if we have to find out the items made up of metals, or the items made up of glass or clay, or items made of other things, then we will find out the most of the things that we have used are made up of carbon or compounds of carbon. So we see that carbon and its compound find their uses in the fields of pharmaceuticals, then foods, fabrics and other industries. Now we will talk about bonding in carbon. So bonding in carbon, as we have seen in previous chapter that we have talked about the properties of ionic compounds. We saw that in ionic compounds there is bonding take place, and this bonding takes place due to oppositely charged ions that attract each other and held together by strong electrostatic forces of attraction. But in case of carbon, as we know, its atomic number, carbon, its atomic number is 6. So, its electronic configuration is like that, 2 and 4. So, in case of carbon, it has 4 electron in outermost shell, but according to the octet rule or the law 2n square, if an element has 2 orbits, then it must have 8 electrons in outermost shell. So, carbon has valency 4 and it needs 4 electrons more to complete its octet, and for that it have to do 2 of the things. For completing its electronic configuration like a noble gas, it can have 2 of the ways. First way could be it can gain 4 electrons, and if it gains 4 electrons, as we are seeing, if it gains 4 electrons, then its number of electrons will be 10. Number of electrons will increase, but now its nucleus have, this is the nucleus and this is the first and second orbit of, in case of carbon, it has 4 electrons firstly, but if it takes 4 electrons or gains 4 electrons, then it will have outermost orbit completed, but in this case its nucleus has 6 protons. So, number of protons will remain the same. So, as the number of proton is less and number of electron is more, now 6 protons in this case will not be able to hold 10 electrons. 6 protons could not hold the 10 electrons. So, that will be, now carbon atom will be unstable. Now, second case is if it lost 4 electrons, if it lost 4 electrons, that then its second orbit will be finished, it will have only 2 electrons, but in this case its nucleus will have 6 protons. So, when number of electron is 2 and number of proton is 6, now 6 protons in the nucleus of carbon will not be held strongly by 2 electrons, then it will be again unstable. So, from the above discussion, by gaining or by losing, it is proved that by gaining or by losing 4 electron, carbon cannot attain stable electronic configuration, hence it cannot form electrovalent bond. So, how do the carbon solve this problem? So, carbon overcomes this problem by sharing its valence electrons with other atoms of carbon or with other atoms of other elements. So, as we know, the carbon has 4 electrons in the valence shell, and in order to complete its octet and attain a stable electronic configuration like that of its nearest noble gas, like that of neon, because atomic number of neon is 10 and it has stable configuration, mean it has 8 electrons in outermost orbit. So, if carbon has to complete this orbit, then an atom of carbon has to share its 4 valence electrons with other atoms, and this could be like that. It has 4 electrons in outermost orbit, and therefore, the number of covalent bonds that will be formed by a carbon is 4. Mean here it will make 4 covalent bonds, hence carbon atom is called tetravalent, and tetra mean 4. So, carbon has to form the bond, and this type of bonding of carbon or this type of bonding is called as covalent bonding. So, covalent bond is a bond formed between 2 atoms of same elements or the atoms of different elements by sharing of electrons, and this is called covalent bond, and this type of valency is called as covalency. So, today we have discussed bonding in carbon. So, that is all for today, and next turn we will talk about other terms related to this carbon compounds.